Good day, everybody. At this point, I will be having a short lecture about electrical measuring instruments. This is part of our lectures and discussions on MELC number 7. Let us start with the specific objectives of MELC 7. By the end of this session, you'll be able to describe how to connect a voltmeter in a circuit to measure voltage, describe how to connect an ammeter in a circuit to measure current, and we'll be able to describe the use of an ohmmeter. Let us start first with defining what a measuring instrument is. We have two definitions here. The first one says that it is a device used for comparing the unknown quantity with the unit of measurement or standard quantity. So I think the keywords here are one, comparing, number two, the unknown quantity, and you have the standard quantity, right? So usually the standard quantity, this is set by the scientific community, and this is based also on agreements, no, and different accords. And then you compare the unknown quantity, which means that's the one that you're going to measure. And basically what happens in measuring is you compare that against a standard quantity. The other definition here is much more comprehensive. It says that it is an instrument or defined as a machine or system which is designed to maintain functional relationship between prescribed properties of physical variables and could include means of communication to human observer. So what I highlighted here are two terms or two phrases. You have here functional relationship, no, between your physical variables, and this could also mean providing communication to human observer. It just says that you are provided with the certain information you wish to know about a certain physical property, no? So this is the general description of a measuring instrument. And as you can see here, when we talk about instruments, there's actually a certain categorization, or there's a certain groupings or classification. You have the three types. You have mechanical, electrical, and electronic instrument. So technically, there's I think we're quite familiar with the terms mechanical, electrical, and electronic, right? And I think it's easier to distinguish the differences between mechanical and electrical, and the differences between mechanical and electronic, right? However, there are lots of instances which we conflate or which we interchange the terms electrical and electronic. So technically, there's a difference between electrical and electronic, particularly in our discussion in our context, no? So hopefully we can discuss that in a different session, but for now let us focus on electrical instruments. So under electrical instruments, you have two types: the absolute or the indirect, and you have the secondary or you have the direct instruments. And then under the secondary instruments, you have analogs and the digital instruments. And analogs are further classified as deflecting or null deflection. And under deflecting, um, it has a subcategories. They are the indicating instruments, integrating instruments, and the recording instrument. So the main two categories or classification of electrical instruments given the absolute and the secondary. So for the absolute instruments, these are the ones that give the quantity to be measured in terms of instrument constant and its deflection. So an example here would be a tangent galvanometer. Meanwhile, your secondary instruments, the deflection gives the magnitude of electrical quantity to be measured directly, and usually these instruments are required, no, to be calibrated. Of course, you compare it with another standard instrument before you use it. So these are the ones that we commonly use, or electricians commonly use: your voltmeter, your ammeter. And these are the things that we will focus in this discussion. When we talk about secondary instruments, we can classify it as analog or digital. No, um, analog instruments are still being used up to this day. These instrument whose output varies continuously, and the analog instrument has the pointer, no, that usually shows the magnitude of the measurable quantities. Um, with the continuous upgrade of technology, we already have the digital instruments. The output that you see uh, no longer requires like a pointer, but you just have a numeric output. Now you will see the numbers or the readings right away. And this is said to be more accurate. Well, it depends also on the instrument, no? And of course the brand, and of course your in your use. But this is said to be more accurate since your error in reading is less compared to the analog, because it's really based on your eyes, and sometimes it's very subjective also and depends on the person. But the digital instrument provides you a much more accurate reading, because it is providing you with a numeric form. Um, if we have to choose between digital versus analog, well, it actually depends on the situation. It actually depends also on the type that you're, or the type of property that you wish to measure. So let's us discuss the specific types, no, of these digital and analog instruments. Usually we have the deflection type instruments. We have the indicating, the integrating, and the recording instruments. For the indicating instruments, this is an instrument that indicates the magnitude of the measured quantity, no? And usually, this is the ones that we will discuss: the voltmeter, the ammeter, and the power factor, no? Your integrating instruments, what you are measuring here is the total energy measured with respect to the time and other measures of electrical quantities. Like for example, your watt-hour meter, your energy meter, and other integrating instruments. And your recording instruments, this is recording the circuit condition, no, at a particular interval of time. And the moving system of the recording instrument carries a pen which touches a sheet of paper, and the movement of the coil is traced on the paper sheet. So we focus more on the indicating instruments: your voltmeter, the ammeters, and your ohmmeter. Let us begin with the ammeter. So the very core use of this is to measure electric current. So as shown on the pictures, you can see here different kinds, different scales of ammeter from the words Ampere Meter. Now, to measure the current through a device or component, you place your ammeter in series with the device or component. So I think what's noteworthy here is the placement of your ammeter, which is, or which should be, in series with the device or component. So you have two possible cases. Like in case A, as you can see, if your ammeter is used to measure the current through two resistors, you connect that in series to a battery, no? So the ammeter is placed in series with two resistors because the current is the same through the two resistors in series. So as you have learned in junior high school, um, when you have a series circuit, no, the resistors will experience the same current, no. And then for case B, two resistors are connected parallel in a battery. So you have here resistor 1 and resistor 2. They are connected in a parallel manner. And it's very necessary to measure the current from the battery here. All right. So you place an ammeter here, or you read the current here. And of course, you also read the current here, and you also read the current here using your ammeter. So you connect it in a series manner because there will be now a change, no, in terms of the electric current reading. No, if you just measure it in this point, or in this point, or just in this point. So that is how you use your ammeter to measure electric current. Ammeters should have very low resistance themselves, no? Because if the ammeter will have high resistance, then definitely it could significantly affect the flow of current, no, in your circuit. So the ammeters normally they contain fuse. In case that there will be too much current, then they can be protected, no, from any damage. So similar with our household electrical system, we also place a fuse, no, to protect should there be a surge of electric current, especially when there are power interruptions. No, so the same technology is installed in your ammeters. Let's proceed to voltmeters, or the voltage meter. Primarily, this is used to measure electric potential difference, or what is known also as voltage. No? So this is how your voltmeter looks like. This is like an analog type. If your ammeter is to be connected in series with the component or device, your voltmeter, on the other hand, should be connected in parallel with whatever device it's measuring. So a parallel connection is used because objects in parallel experience the same potential difference or voltage. So we just have to take note of the placement with respect to, say this is R1. So we have to place it in parallel and measure the voltage at that point. No, so we should always measure it or place it uh, with a parallel connection. Now, unlike your ammeter, since ammeter is supposed to have very low resistance, your voltmeter must have very large resistance. On the contrary, you have two types of voltmeters here, the digital and the analog. So in our physics laboratory, I think we both have them. But most of the ones that we have are the analog type. So your analog type uses a galvanometer to measure the voltage. And what's happening in your digital is much more complicated process. You are using an analog to digital converter to measure your voltage. No? So basically, you convert the analog voltage into a digital value so that you can see there as red as 5.77. So that is for your voltmeter. At this time, let's proceed to the ohmmeter, or this is the resistance. Or is that the voltage meter? So this should be the resistance meter. No? Let me correct that. So since it is a resistance meter, this is used to measure your electrical resistance. So an example of an ohmmeter is shown here. There's a symbol ohms. Now in series ohmmeter, the measuring resistance component or circuit is connected in series with the meter, right? So this is what we call the series type ohmmeter. So since as the name suggests, this must be connected with in a series manner, in a series connection. So you have here the ohmmeter here. Okay. Then the next one is the uh, shunt meter or the shunt ohmmeter. The shunt ohmmeter is measuring resistance that's connected also in parallel with the battery, and this is usually used for low value resistance, no? Like you're going to measure resistances that are of minimal amount. So this is the setup for a shunt ohmmeter. You place it parallel with respect to the battery. Then to be more flexible, if you have, say, low-level resistances that you want to measure, and you also have the mid-range, or you want to have high range of resistance, you can make use, instead of having the shunt meter and the series ohmmeter, you can make use of the multi-range ohmmeter. No? So the range of this ohmmeter is very high. So you can have just, or you can just manipulate the adjuster so that you can select properly the range according to your own need. No? So I think this is a much more convenient type of ohmmeter. So I think that is the short, or that is, those are the pieces of information that you need to know for now about the basic properties and basic use, basic functions of the ammeter, voltmeter, and the ohmmeter. Thank you very much, everybody, and I hope you learned something from this discussion.